Ever wondered how your smartphone screen turns off when you hold it up to your ear during a call? That's a proximity sensor at work. These ingenious devices can detect or sense the approach or presence of nearby objects without any physical contact. Imagine the convenience that brings. Proximity sensors come in different types, each with its unique features and applications. We have inductive sensors, which are great at detecting nearby metallic objects by creating an electromagnetic field around themselves. Then there are capacitive sensors, designed for detection of both metallic and non-metallic objects. Photoelectric sensors use a light source and receiver to detect objects, while magnetic sensors operate based on the presence of permanent magnets in a sensing area. Each type of proximity sensor has a unique mechanism and specific applications. So, let's dive into each one and see how they make our lives easier and our devices smarter. Inductive sensors are the detectives of the metal world. These clever devices use electromagnetic fields to sense the presence of nearby metallic objects. The heart of an inductive proximity sensor is its coil. This coil, when energized, creates an electromagnetic field around the sensor. But wait, there's more. An electronic oscillator comes into play, driving the coil to generate this magnetic field. When a metallic object enters this field, it disrupts the oscillator's rhythm. This disruption is then picked up by the sensor's detection circuit. The detection circuit isn't just sensitive to these disruptions, it's tuned to them. It's constantly monitoring the oscillator, ready to detect any changes in its frequency. Once it detects a disruption, it sends a signal to the output circuit. The output circuit then does what it does best. It generates an output, alerting the system to the presence of a metallic object. So in essence, inductive sensors are widely used in industries like automotive, metalworking, and more. Capacitive sensors are not just about metals, they are also about non-metallic objects. These sensors use an electrostatic field rather than an electromagnetic one, which allows them to sense a wider range of materials. So whether it's a metallic object, a liquid, or even a sheet of paper, a capacitive sensor can detect its presence. Now let's shift our focus to photoelectric sensors. These sensors operate a bit differently. They use a light source, often infrared, and a photoelectric receiver to detect objects. Simply put, if an object interrupts the light beam between the source and the receiver, the sensor detects it. There are four main modes of photoelectric sensors. These include direct reflection, retroreflective, through beam, and distance measuring. Each mode has its specific applications and uses based on the nature of the object and the environment in which it operates. Capacitive sensors find their use in industries like food and beverage, while photoelectric sensors are used in various automation processes. Last but not least, let's talk about magnetic proximity sensors. These sensors operate based on the presence of permanent magnets in a sensing area. At the heart of a magnetic proximity sensor, we find a reed switch. This switch is an electrical circuit controlled by an applied magnetic field. Imagine a pair of flexible, magnetizable metal reeds, separated by a small gap. These reeds are sealed within a glass envelope, and their inherent stiffness maintains the gap, keeping the circuit open. When a magnetic field is applied, the reeds are attracted to each other, closing the gap and completing the circuit. This change signals the presence of a magnetic object within the sensor's proximity. From smartphones to industrial machinery, proximity sensors play a crucial role in our everyday lives. They truly are the unseen heroes of the tech world.